and introduce our guest of honor. Okay. Um, on my screen, he's in the middle, which is great. He's probably elsewhere on other people's, but he'll probably migrate up to the top as he starts to talk. The Zoom algorithms are weird. But it's Ethan Edwards. Ethan actually did his undergraduate degree here at Columbia. Just a little bit of a background about him in philosophy, which I think is kind of fun. But during his time as a philosophy major, he managed to take a bunch of the courses that we offered at the CMC and became kind of intrigued by this bizarre music technology. Then he left and he went to live in Japan for a year and worked for a gaming development company over there, taking some of his newfound technical knowledge and applying it to earning money. And then we convinced him to come back to our sound art program, and he got his MFA. It was 3 years ago, I think now, 3 or 4, I can't remember. Yeah, three
I
years.
think it's 3. I
Yeah.
hope it's not 4.
Yeah, I know. Time flies when you're having fun, huh? But he got his MFA, and his project. He's the one that introduced me to Unity. He said, "Hey, Brad, you ought to check this out." And I'm going, "He's stupid, silly stuff. I'll just make some sounds." But he showed me what it was capable of doing, and I just was totally bitten. And then we worked. A bunch of us worked on getting RTC Mix put into Unity, and Ethan did one of the first major projects with it. His sound art MFA thesis was a big augmented reality piece that I think you're probably going to show some of it today too. Where, yeah, well, I'll let him do it. But anyhow, he's gone on to bigger and better things. Upon receiving his MFA, he got a job offer and is now working at Nokia Bell Labs in their, I love the acronym EAT, Experiments in Art and Technology. This is actually a very venerable program. It dates back to like the late 50s, I think, and 60s. And it's a commitment to doing research that's actually kind of interesting. So he got a pretty cool job, and we're really happy to have him here. And I'll let him take over and show you what he's going to show. All right, Ethan. Thanks.
Yeah. Thanks so much, Brad. Um, so I'm going to be talking broadly actually about some of the stuff that Brad has just discussed, kind of my background, but especially the goal of this hopefully is to give a better sense of what it is I actually do, and hopefully through that kind of investigate generally what people with the hybrid set of interests that are usually attracted to this grad seminar might also be interested in. So I'm going to go through some concrete things. I'm especially going to focus on different projects I've done in Unity, and then conclude with kind of some speculation, more or less, about what might be possible. But at any point, please do interact with me. It's no problem at all to just unmute and ask questions. I'd love to have discussion. I'm going to try to make sure I have enough time for discussion. Yes, Brad?
Right. I was going to say, when he goes to screen share, I'll be monitoring the chat and everything. So because I know Ethan won't be able to see everything, but otherwise,
Great.
just yell out your questions because he's a yellable kind of guy.
Yeah. But yeah, I'm hoping, I imagine there's a lot of different projects that are going on, a lot of different sets of backgrounds and interests, but it's certainly, I don't know, when I was back in this position, both when I took some classes with Brad in undergrad as well as in grad school, I didn't necessarily know about the things that I'm going to be talking about. So part of it's just hopefully to give you some idea of what's possible with some of this technology. So I will, oh, apparently you are sharing computer sound, so I cannot share screen at this moment.
Sorry about that. I was forgot to turn it off after King Crimson. There you go.
There we go. Yeah, and let's share my whole screen. All right, you're seeing the slide deck all right? Great.
Yes.
Awesome. So I'm using my Nokia slide deck format. Some of the stuff I'm talking about will be internal work stuff, so please don't share it with any of your friends who are like, secret agents for Huawei or whatever, but generally the stuff I'm going to be talking about is mostly about public projects and not particularly crucial anyway. But my subject is what is art and technology, because a lot of people have probably heard this phrase art and technology, don't quite know what it means. I'm now, I guess, 3 years into working in it. I'm still not quite sure what it means, but I think I have more of an idea. And that's part of what I want to talk about. So this was kind of a nice, overly ambitious stock image I found. I think it's the first thing that comes up when you Google arts and technology. And it's this idea that there are these two realms that are totally disjunct. You stick them together and then something magical happens. No one's quite sure exactly what, no one's quite sure what to point to concretely, but this is the story. So I have this next slide, which actually comes from my boss, who I'll talk about a little bit more. But just generally, vaguely, you've got two sides to it. There's the technology side, which tends to be engineers, scientists, STEM, whatever, which has this qualities in general of reductionist, linear kind of thinking, logical style thinking that's crucial for getting things done. You have the artist creative side of things, which are much more expansionist, trying to find different way things relate rather than reducing them to understandable quantities, non-linear, illogical. The idea is that we fuse them together, have this nice line, and have everything melded, um, best of both worlds sort of scenario. And I think a lot of this is true. I think a lot of this gets overemphasized within arts, within technology, within industry, within all of it, that really everyone has all of these capacities. And it's more a matter of we often just don't use them. We're sort of trained out of using certain parts of capacities, both individually and organizationally. And a lot of what I'm going to be talking about is sort of just really going slightly beyond and trying to have a little bit of both. But to talk a little bit more about art and technology, concretely, you have these companies that are art and technology companies, and these are the kinds of people and organizations that I was looking at when I've been looking for work. As someone who took some computer science, had sort of a background in doing things with computers generally and interest in doing things scientifically, but then also had this interest in art, this was mostly what I came to. So Fake Love, unfortunately, departed now, was the sort of art and tech, uh, I guess almost like a startup or an incubator within the New York Times. Team Lab is a famous Japanese company that do all these big installations. Zach Lieberman is an independent artist who's actually really generous with his time. He's been very, very helpful to me, even. He does an open office hours things, but behind open frameworks, which I know Brad has also used a lot. But all of these things are doing art and tech. They're making money as art and tech agencies. Um, and what that ultimately gets to when you really, really probe down is it's some form really of really marketing or advertising that Team Lab, for example, is able to get very, very good funding for their different installations, which are incredible and you should see them if you're local. But those are ultimately, they're doing these nice company partnerships. They're actually able to make art that can sell, something that is rare and that certainly a lot of people, myself included in the composition program, not only wouldn't dream of being possible, but aren't even particularly interested in. You have people like Zach, who's making his own art, he's able to sing himself. He's also doing it through, working on contracts, being able to set up things nicely for people. And a lot of these things are ultimately about partnering with the business world, with corporate world. Maybe you can get an educational sponsor in making something that enhances their brand, does something like that. And that I wish people had been more explicit with me that that is how most art and tech companies are, that when you look at the bottom, you're making something that's flashy and nice looking for ultimately the companies that draw their revenue from other places, but it is mostly true. Um, Talk a little bit about the position that I would say, lucked into. There's there's some jobs like this, and I think they're becoming more frequent. But I especially don't want to convey in this that there's a lot of things doing, and if you just study the right things, you'll definitely get a job exactly like mine. I have no idea actually how rare or how common this is. I'm hoping it'll be more common, but hopefully understanding some of this stuff will help there be more of it. So generally, I work in a three-person team. In the bottom left there is Dunal Hernan. He is the head of experiments out in technology in the revived form. He's actually got quite an interesting background where he has a PhD in aeronautical engineering. He did it purely through an engineering course. Began at Bell Labs heading the team on thermal research, eventually wound up heading like these large development teams dealing with really key products in the Bell Labs pipeline, and then said, I'm really interested in this stuff, but I think we don't have enough creative thinking, so want to run EAT as kind of a more full-time investment. So he was able to hire me on, and then was also able to hire on the top left there is Danielle McFadder. And pretty much all the projects I'm going to be talking about Bell Labs are a collaboration between Danielle and I. We both have a hybrid background of interest in music, especially interest in game design and Unity, and then applying that to the different projects that you're going to see. But generally, the idea is that as a team, what we do is, first off, we work with artists. We are doing these big collaborations where we bring in some either well-known or up-and-coming artist into Bell Labs. We have them talk with the engineer, and then hopefully they will produce some sort of artwork that speaks to new insights in technology, does something really interesting and creatively, and important to acknowledge, falls under exactly what I've just discussed, where this, is really good for the Nokia and Bell Labs corporate brands. That the fundamental reason why most companies do artist residencies is for this reason. And Google, Facebook, all of them have different kinds of programs where they want artists to use their technology, because it makes what is sometimes quite boring technology more exciting to have it used in this public-facing artistic way. So we do that, but we do have a real earnest desire that we're fortunate enough to be supported within the company to do more than that. When we talk about collaboration, we always set as kind of our key criterion for something that's successful, that the project that ends up coming out, either to the public or internally, is something that neither the artists or the engineers would have thought of alone. If something's really going to be a collaboration, there has to be a really significant give and take. And ultimately, we want both to be doing research. Research meaning that they are really discovering new things that can be applied. So with engineers, it's pretty obvious. It tends to be more obvious what research can mean. And often in a Bell Labs and in a hardcore environment generally, research is something that you publish papers on that has some advancement. And especially Bell Labs is a networking company. We've focused on these kind of little incremental advancements. If we can reduce latency by a couple milliseconds, that would be an advancement. With artists, research is often not the phrase that people use, since there's a lot of discussion of personal expression, but there is quite a lot still, I think, of discoveries that artists make, that someone does something artistically that really opens the possibility space. I don't know, Brad, how much you've talked about it, but if you look through computer music being such a new field, there has been a lot of really important research of people not only making really incredible pieces, but through those pieces discovering new techniques, new ways of thinking that open things up. And I think that the real insights that we think at Bell Labs are going to open up things combine them both. That you want something that not only drops bandwidth or advances something incrementally, but can actually really fundamentally change something about how we communicate. So to think about what that is, we like to go back through the history of Bell Labs. I'm not sure, people probably have varying levels of familiarity with Bell Labs as an institution, but we do a lot. Bell Labs was the sort of research wing of AT&T back when AT&T was the telecoms monopoly of the United States. So from, I guess, the early 1900s through till the mid 1980s, the only real phone provider was AT&T, who had a total vertical monopoly. And part of the way they justified that to the US government was research labs like Bell Labs, which were making these fundamental discoveries that they felt advances the public good of the American people as well as the whole world. So the bottom middle image here is the transistor, which was invented at Bell Labs as this fundamental breakthrough in communications technology, but ended up really sparking a lot of the electronic revolution of the post-war era. You have the first communications satellite here, the horn antenna that was originally invented to do the first sort of tests with sending signals through the air by bouncing them off a hot air balloon. When they were done with that, they had finished their communications usage. They handed it over to the fundamental physics researchers they also employed, who then ended up confirming the Big Bang with it using the cosmic background radiation. The top left is Claude Shannon, who, right, also was someone who would not normally be kept on in a very bottom line conscious research organization, right? He wasn't working on how to make a better telephone, certainly nothing that would translate to anyone in corporate's idea of how does AT&T make more money. He was a mathematician who worked by himself for years and years and didn't really tell anyone about his research, and then ended up inventing the mathematical field of information theory, which has proved to be really, really applicable in all these different ways. So Bell Labs really, especially in the post-war years, was one of the sort of shining centers of American technological advancement. Had collaborations with all the different countries, really supported a lot of the fundamental technology that we use today and is fundamental. Unix was invented in Bell Labs in the late 1970s, which still underlies a lot of the computer systems we use. And hopefully we're all using it a little bit in this class. And during that heyday, there was this program called Experiments in Art and Technology, which was from the idea that scientists, especially scientists at the forefront of their fields, should be working with artists who are at the forefront of their fields. So Billy Kluver was a trained Bell Labs engineer. He had all the normal credentials of a purely technical PhD doing purely technical research, but also had a really deep interest in art, and especially in the art that was going on contemporaneously in the late 50s, 60s in New York City. So he was personal friends with folks like Robert Rauschenberg, John Cage, all these different kinds of people, and really believed that to do the best work in both worlds, you should have both involved. So he started the program of Experiments in Art and Technology, first kind of, I think actually really throughout, mostly clandestinely, where the bosses at Bell Labs typically looked the other way for what the engineers were spending their time on. And it was never sort of officially blessed or officially funded, but you did have the top engineers, especially in the communication system, working with artists on what's something that they need their help to realize. So you have things like the 9 Evenings, one of which at the Park Avenue Armory was people in the 1960s playing tennis with wireless receivers hooked up to their tennis rackets and triggering sounds every time they hit the ball. They would trigger a gong and the light would go off. They kept playing the game of tennis until all the lights went off and they were able to turn on what was basically a really early augmented reality display of a thermal image of everyone in the armory. It all kind of culminated in the 1970s with the Osaka Expo, the Pepsi Pavilion in the bottom right there. And, you had people doing really fundamentally new scientific and artistic research at the same time. His involvement was a little more minor, but one of my favorites is Namjoon Paik, who I consider to be someone who really put forward a lot of original concepts in art, especially responding to technology. And he was fortunate enough that Bell Labs said, hey, you can use our systems, you can start playing around with experimental drawings. And this is something which, I think was a really, really excellent use of resources and made some serious advancements, but isn't so much done now in this same model, right? The Pepsi Pavilion is called the Pepsi Pavilion because it was Pepsi sponsoring it, not AT&T or anything. There wasn't even the corporate sponsorship angle I've mentioned. This was really researchers, because they were the top researchers and they wanted to push to the limits of what they can do with human experience. So now we've tried to revive it. Right now it is actually fully sponsored by the company. I was the first full-time hire of the program. We work with a whole bunch of different artists. Maybe you've heard of some of these. A lot of them you probably haven't. I'll send links afterwards to Brad that you can check out some of these projects. But the heart of what we're doing is working with these artists and not just dealing with them on how can we make your project cool in a way that we can attach our logo to, but how can we make something that really advances to EAT's fundamental goals. And in this case, we are trying to think very deeply, not in the horizon of 1 or 2 years, maybe 5, probably more like 10 or 20 years of what are the fundamental parts of the human condition, of really the sorts of things that artists think about that current technology is missing. That how can we make the next paradigm in technology be really mindful of the human experience, especially as so much of current technology and current companies are ignoring that. Do I see a question or anything?
Oh, Nina just posted a link to your
Ah,
opportunities. Yeah, she's pretty
awesome.
sharp. Okay.
Great. So now I'm going to talk a little bit more about me and how I ended up getting involved in this and what I think is going to happen. So I have a patchy background. As Brad said, I studied philosophy first at Columbia. Um, Thought I was going to, needed to get philosophy out of the way, solve it first before I do anything else. Didn't end up solving it. Also realized that I maybe didn't want to work in the field, so ended up taking some computer science classes. And really, when I've gotten paid as well as in my grad school, it's been through computer programming and such. And I'm not really the best sort of hardcore engineer, I would say, at programming. I can write program, I can make things, but I really like to use the description when I'm being honest and candid with people is that I'm much more of a bricklayer. And you may have encountered this phrase. It's a French one. It's been made to mean a million different things. I first encountered it, I think, in post-structural French theory, but what I'm using it to mean here is that I'm really kind of a kitchen sink programmer. I will take whatever I can get in order to make something work. The assembly is ultimately called a bricolage, which is usually some kind of messy collage or just sticking things together. And I know Brad can also definitely identify with this method of working that what we're really trying to do with technology is to make something that works. It needs to work right, it needs to work well, otherwise it's not going to deliver the experience you want it to, but you want to be able to just take whatever you have that's available and use it to make the project. And one of the key tools that I've used and will continue to use is Unity. So I'm going to be talking about some of the really varied kinds of projects that I've been doing that hopefully can be an inspiration to you, maybe with your projects, which I hope you're far along with, but also just in the future for what you might do with what you've learned from Unity, as well as especially what you've learned specifically when thinking about the sounds and the different things that are still unexplored with it. So I've made a bunch of different personal projects, a lot of them with Unity, a lot of them not. These images are from my MFA thesis, at least these ones on the left. I had everyone, rather than have a piece in the gallery that we had, I just had people bring their iPhones, have a QR code, download the app, and experience it in the space. And I had an augmented reality, really just full narrative experience. So what it was people would start it up. They'd be kind of guided through just, you're supposed to walk around, hold your phone, move around, and led them through little narrative, had music being generated with RTC mix at all the different points that I wanted to fit thematically. And that was with the idea of making something that can really be the sort of narrative art that I wanted to make using this new thing of augmented reality. And especially having it be in people's own spaces, I thought would be powerful. With right, with music programs and with art, you get a lot of talk about performances and galleries. And I know both Brad and I share as a just kind of personal preference that we experience the best art in our own rooms, listening to music or reading a book or something. So I wanted to see, how can you take some big multimedia experience that normally would be on some special hardware and just make it in someone's phone. And then also just to mention, the thing on the right here is, I'll see if this actually works, but it's just a edge separator using some computer vision and generates sound using the different lines. But these were the kind of projects that I made just independently. And now I'm going to talk into a little more of these technical things. So this image that you see on the right is from a project called Lazy Arms. This is the first major project that I worked on as an actual hired person doing things. The company I worked for was called Daisy. They were based in Tokyo. They actually explicitly billed themselves as an art and technology company. I sort of came in with an interest vaguely in game design, but more with an application towards art, and happened to just get lucky once again with them looking for someone like me. And the way this project started was the CEO of the company wanted to make something that would work well at trade shows, but that especially could showcase a sort of device hybrid way of doing things. He specifically said IoT as one of his phrases, Internet of Things, as something he was interested in me. And the way I got involved with it was that I wasn't doing much. My Japanese was pretty poor. This was still during the time when my coworkers would refer to Guguru Sensei or Google Sensei to do Google Translate as they're giving me instructions. And at one point, one of my managers came to my desk and said, Ethan, uh, Eduardo-san, do you know Arduino, this physical computing thing? And I said, no. And he said, okay, start learning this. So I had no real background in it, but it was just thought that because I was the foreigner, I was the new guy, it was good to just throw something at me. And what we ended up doing was a hybrid Arduino and Unity project to make this thing work. So if you see on the right here, you've got this appendage. There are, I guess, 8 little robotic arms that are all controlled via an Arduino board, and then attached to them all are LED light strips, which are also controlled via Arduino. I was given a basic Unity project, and the goal was to make a functional and interactive system that used the Kinect camera to track people's motions. And then as they're moving around, the arms move and the colors move accordingly. So it seems, right, no one will ever see a Unity thing when using this, but it turns out Unity was actually the perfect thing to be stitching things together. There was a nice feed in to connect. It also had a quite easy way of doing the Arduino system, and especially you can see in my little scene view here that there are these animated arms. It was very useful actually to have just a little simulation of the arms, because what we could do is, there were animators at the company. They were able to make animations using this 3D model. And then we just had a very simple algorithm that could translate the positional coordinates of the different parts as they're moving through the animation. And then having that actually move the physical system. So
So So Unity was
Mhm.
just used for the development of it. You did, it wasn't part of the final product or anything like
No, it
that,
it
huh?
was running real time all throughout the
Ah,
product. Every time this is installed, and it's been installed in a few places, there is a computer that is running Unity. There's no reason for users to see that it's all being run through Unity. From their perspective, there's a camera and the robots are responding. But it's a very nice hybrid system, and I'm very glad actually that Unity around this time was leaning much more has been leaning much more into creative coding in general rather than strictly for video game design, which is right their bread and butter. So these sorts of hybrid systems end up being really useful in Unity, and there's even a bunch of projects that I've done at this job that I won't necessarily talking about um, that used Unity in a similar way where you're not seeing it, but it's just a really good way to tie things together once you get a handle on it. So the next thing, you know, fast forward an MFA degree later, and I am actually working at Bell Labs. Once again, I've had a crazy deadline where I had to figure out a new haptic vibration system to coordinate a musical performance to, which was a whole other story. But I'm mostly going to talk about Unity now. And this was the prompt of we're new in the organization. We need to prove that, not only can we do these cool artistic collaborations, but we can also do things that deliver more internally. So this was a specific prompt from an internal lab in Bell Labs that did software systems and especially dealt with the core business, which is networking. And they wanted some way to be able to make their tours much more interactive and compelling. A lot of what Bell Labs has done, right, is they will talk about the future of networking to people like Verizon, AT&T, all the places that used to be owned by Bell, who are now the customers. They use Nokia infrastructure. Nokia, right, is the people making all the giant 5G cell towers and stuff, and then Verizon, T-Mobile, Sprint, etc are the customers that are just using those networks. So that's Nokia, Huawei, and Ericsson are the three competitors in that space. But we were just trying to show some new 5G things and especially wanted to do it in AR. So once again, this was a case where neither Danielle or I had really used the HoloLens, but were given HoloLens and told, okay, build this thing, make it so that it actually works. Um,
uh,
so,
you might want
mhm,
to explain a bit what a HoloLens is. I haven't talked about it at
yes.
all in the class. So,
Yeah. So a HoloLens is Microsoft's augmented reality headset. It's kind of a visor like this. You can look it up. It's probably at this point the top of the line for augmented reality proper headsets. I still prefer developing on smartphones for augmented reality, but it's quite good, and especially Microsoft is trying to focus on industrial applications. So people in warehouses and stuff who can use augmented reality displays rather than necessarily art focused, but it is a good device, and especially their HoloLens 2, I would say is probably the top of the line. But we were using the HoloLens 1, still really sort of a rough device, and we in Unity were able to follow some tutorials, figure things out along the way, and get things working. All of these things that you see on the screen were actually animated, and weirdly enough, the I don't even know if I should be talking about this. I guess I should take full credit for it, not to reflect poorly, but in the early version of this, the key thing was to make sure that it worked with the rest of the demo. So what you had was basically executive level president type figures within Bell Labs giving tours to these very important people. And they had a way to trigger different slideshows, different parts of the exhibition. And we needed to make sure that what could be seen on the HoloLens would be things that were actually corresponding in real time to what the person was saying. And we could have done some fancy system of speech recognition or done really hardcore engineering to make sure there's a proper networking tunnel for this. And that's what one should do if you're going to make a real long-term viable product. What we were doing was something that was good enough to get by for this specific application. So we just had a little web page on our local network and the Unity application is just checking that every so often to check what the status code is, what number slide you're on, and then change the animation according to that. And that's really what I mean when I'm talking about bricoleur sort of things, is that Unity and networking, at least at that time, was sort of, you have to go through all these, GitHub repos that are, 8 months out of date if you're lucky, probably more like 3 years to figure out some kind of stable messaging pipeline. But what we cared about was making it so that the people going on the tour could have the experience they needed. And that was the way we found to do the most flexible way within the deadline that we had. Brad, did you have a question?
Not a question, just more comments. First of all, people should realize this HoloLens, one of the features is that it's a shared experience. Rather than a single goggle, you've got people that all see the same thing from their particular perspectives and things like that. And it's funny, the what you mentioned about checking the website, that's basically how those interactive book things that I did work. It
Yeah.
just checks what page number you're on. It doesn't do any fancy lip reading or anything like that.
Yeah, I've previously given a talk to some creative technologists on how to make your systems reliable. And often the system is actually, especially if you're targeting a performance or something, it's not to do what, sane sort of like network experts would say, because they'll give you a very stable pipeline that requires a couple years of engineering until the standard changes. You want to always be thinking about what is the best system that you can guarantee and that will work on the day of things happening. So that was another early one. And these, though, still right, are ultimately going with how do we present things in a nice, flashy way to people? How do we do things that will inspire whether they're customers or the general public to think that we're really cool? And I do want to get more into some of the stuff that hasn't been tapped yet, but is very much alive, of these concrete deliverables, whether it's to industry or something else. Um, so this is a project that we're still kind of working on, and I won't say too much about the fundamental goals, but it's really with the goal of how can we sort of propound and really build what constitutes the ultimate map. And if you think about maps, right, they're pretty generic. I would actually say that maps have gone a long way, right? If you go from a road map to something like Google Maps, which is actually very useful and has some key features, we're trying to make that sort of status upgrade, but for something that is a little more focused and specifically looking on building environments and cases where you really need to know not only where you are, but where a bunch of people are as well. So this was absolutely something that we wanted to do in Unity, right? The
Um,
the best, go ahead.
yeah, yeah. I was going to say, isn't the ultimate map that Borgesian thing, where the map itself is exactly the size of the country that it's a map of?
I'm gonna get into that actually.
Okay, okay, okay. Sorry, I didn't mean
Yeah.
to jump the gun.
That'll come later. This is the ultimate map with current technology, I'll say. Um, since I don't know, do we have enough paper for the Borges one? Maybe someone could do a calculation. Um, but this was specifically looking at how can we show facilities with all the possible information we have. Bell Labs is fortunate to have a lot of sensors, so we were able to build this out sometimes with real actual data. But the big thing was to have a bunch of different people in the space being tracked and seeing what we could do with that, what we could showcase. And we came up with some really interesting things. We were one part of a much larger team working on this problem. And as the people who work more with artists who have this creative background, we were kind of the people trying to really get the big ideas and figure out what are the use cases that we might not be thinking of. So we looked at things like, can you show heat maps of the space? What are the kind of heat maps you'd want to show? A standard one we talk about is network reliability. COVID-19 hit, so then it became, how do we show things like airflow? How do we show the sorts of movement that's been in the space? That's something that Bell Labs engineers have worked on, for example, is movement, say within a traffic intersection for smart city projects. That then suddenly became more applicable in COVID-19 as we're thinking about how can we keep people moving in different spaces and that being sort of a key feature of infection. Um, and these were the sorts of questions we asked. Another thing that we had was, what if we wanted to make the system generic? Would there be a way, if you're just given a whole bunch of coordinates, that you can build a bunch of buildings? And this was something that we stuck a bunch of things on, using different Unity packages, and found that, hey, we can go through the mesh geometry, we can go through the shaders, we can build these things and have Unity do what we need to do for this project. I'm just going to quickly check the chat here. Ah, Sims 4, yes. Very similar. Um, so ultimately, what we ended up building was a showcase of what we think some of this is going to be that ends up having some real industrial usage. We specifically were trying to focus on this potential use case. I'm hoping it won't be as necessary now that vaccine have proven to be so wonderfully quick, but looking specifically around different infection scenarios and what kind of information people would actually want to know if they're running a factory space or these sorts of things. So thinking about, can we track social distancing? Can we track whether people have masks? Can we send robots to people when they need some physical object without contact? And the key thing was that we did want to build this in a way that people could actually use, that they could get a strong sense of it. One of the key things that we found actually when doing our first couple demos just internally to ourselves was that we ended up making these things around tracking everyone, tracking all their motions, tracking their health and everything. And from having it built out rather than it just being, say, in a PowerPoint or something, we discovered a lot of it is creepy. That these fundamental invasions of privacy are something that people are legitimately concerned about, that people who work in these environments want to know. So from that, using kind of an iteration, we're able to make a core kind of pipeline for what should privacy be in these situations? What are the different levels of privacy that we need? And that was only through some real kind of empirical experimentation with Unity as our simulator. We could do, and that those principles that we made around privacy and these different systems ended up being very useful just within the larger team. And these were the things that we could discover. And I think a large part of that is, not to congratulate myself on doing the thing that I just said is so hard to do, but that is the sort of research that I think we really need. Is not only to, you need to be able to build the technology, and you also need to be able to simulate it and do it well enough that you can start to encounter these human consequences, which artists tend to be much better at imagining than strict engineers. But you always have this feedback loop of, a lot of times you don't realize the problems until you build it, but you can't keep building it until it's too late. So I'm thinking that that gives a sense of what I've done, and I want to talk about a few things that I'm particularly excited about, specifically in Unity, that I think really speaks to Unity's potential, not just for these art sort of things, but also for general use things, whether that be industry or things that will really be kind of more public. Um, this was a really, really cool project. This, all credit goes to the artist on this one. This was the most recent art project that we did, which was called Networked Ecosystems by two very talented artists we work with, Mark Ramos and Ziyang Wu. I'll have Brad send the link to this, but furtherexperiments.rhizome.org has their project, and you can actually experience this as a live Unity demo. What they were interested in was, we have all these sensors at Bell Labs, we have all these sensors in a lot of different places, and typically the way we visualize them is with something like a graph, right? You have temperature going up over time, graphs, charts, these sorts of things have been done for a long time, at least a couple hundred years. And what they wanted to do was basically take these sorts of data feeds and make them really as weird as possible rather than trying to make them as comprehensible as possible. So what they took was all the time data from a factory space, and rather than making it be like an accurate factory, like the sort of thing that we were looking at, is they made a jungle. they had all these different organisms and things that were responding to the temperature, the air systems. We had all these different environmental systems that were then suddenly transformed into things that were actually growing and blooming and responding to it. Um, they were able to make creatures that behave differently. So it really kind of changes your perception when you think about someone who wants to understand what's happening in environment. The Bell Labs, we have so many sensors that it's actually not the best thing to just look at all the different data tables and try to do out in your head what the average is or whatever. It is these sorts of much more experimental and I think creative uses of data that we think is going to be crucial for understanding basically big data. Another cool thing they did was they have the different named robots in Bell Labs. They have all their different data now personified as animals that are, rather than, it's just reporting the quality of the Wi-Fi signal for future maps. These things that are normally just inert robots are actually responding in real time to the data that they're seeing. So related to robots, oh,
I
go
was
ahead.
just going to say before we left that last one. So basically, it was just like a giant mapping project. Like you'd take sort of a tree and say, all right, the tree can grow up and down, and then we'll feed that with like the temperature variance in the building over a
Yeah,
day or
so
something.
a lot of it was these different kind of agents within their Unity system that were just responding to the different data that was being pulled in real time. And a key thing for them artistically too was that they wanted the data to be as up to date as possible. So
It
part
was real
of
time then. They weren't looking at historical data or anything like that because
they
some.
ultimately were looking at historical data, which is more to my discredit than theirs, since I built the AWS pipeline that they could grab stuff from Unity as quickly as possible and get it, which once again is just figuring out whatever tool is right for the job. I did not know AWS before, but now I
Yeah,
certainly do.
yeah.
But
It's
they
fun.
wanted to, we were trying to keep it updated. Whenever we got new data from the sensors, that was enough to feed them. We keep it updated in the database there.
Ah, got it, got it. Yeah, it's interesting. This is Laura Lewinson talked last week, and she did the same thing with AWS with some of the projects she's been working on.
Yeah,
So yeah, good job.
yeah.
I have a
So,
question.
oh, go ahead.
So your role here was more of a researcher and not also a curator of this project?
We do a little bit of everything. In this specific collaboration, we were working with New Ink, which is the New Museum's incubator, and then Rhizome, which is kind of a venerable art and really art and net art and technological art institution. And they tended to be much more of the curation side, but we would, as the people who we were partially building the tech with them, so we would have all these different creative conversations and really try to understand what are they after aesthetically and what's the best way we can build it. It's very impressive that they were able to do this, since neither of them knew Unity particularly well. But there's little bits of my Unity code, whether they're for loops or arrays or whatever, running on this project now, because we kind of try to guide them every step of the process. But it's great when artists already know technology, but part of Danielle and I's role is to be that kind of gap filler, that we can connect them to the researchers writing the papers, but we also are the people really helping them build the things as much as we can.
Yeah, it looks amazing. And I'm wondering how much time it took to bring it to a presentable level.
Yeah, this was months of work. I think Mark was primarily the programmer, and Ziang was doing all the graphics. This was a little bit of a strange collaboration, because they actually we had everyone come out in the winter of 2019 and connect with the researchers and start doing things. And then when COVID hit in March, everything kind of paused. Everyone just sort of assumed that no art is allowed to happen for the next while. So all of our collaborations froze. We focused more on internal things, but we were able to get back in contact with them more solidly in the fall. And then we actually just had the big debut of this just a couple weeks ago. So if you go to that website, you can see all the projects that came out of that. And I think there might even be a recording of the presentation that we did.
Yeah, I will be really interested
Yeah,
to see
definitely.
a video.
We want these links to put on the webpage and everything.
Yeah.
Another quick question for you. Sorry, but this is just so fascinating to
Mm-hmm.
see. Each image there, about how many different feeds are going into it to kind of create the composite thing?
Yeah, I can't actually say in the final way. We were we were kind of burning the midnight oil to finish this all off. But
That sounds
let's
familiar.
see. I was giving I was giving them at least like 20 different real data streams towards the end per second, per frame or whatever was ended up using. So there was a lot. Primarily it was, I think, 4 or 5 that did most of the work, but we tried to incorporate as much as we could and have it reflect. And hopefully the projects can go on to other places as well, and they'll even change some things up.
Yeah, I could imagine some of the feeds were probably kind of boring. You know, they wouldn't change a whole lot.
Well, yeah, we tried to focus on the ones that change. Yeah, there's some that are less interesting, which of course in itself ends up being interesting, right? I looked through the temperature sensors a bunch of different times, and there was one that was like strictly between, I think it was like 25.9 and 27, but then there was others that were between like 19 and 28, and you get interesting questions of scaling. And when you're looking at data in this way and you have such, right, a temperature change from 25.9 to 27 is not particularly interesting if you visualize it as a graph, if you visualize it as a thermometer, even if you visualize it as changing the temperature on someone's skin. But in cases where it really matters, which there are cases, especially in these kind of industrial settings, you want it to be something that's much more interesting. And that's part of, I think, the magic of this project. So we're next going to be talking about more futuristic things. And these are things that not just us, but people within Bell Labs are aware of and working on because they're so promising. And I do want to emphasize that we're one among many different teams that love Unity and primarily use Unity. There is strictly industrial applications of Unity that, if you're at all interested, you should look into. But I just want to point to Ross Sharp, which is, I think, Siemens, one of the biggest robotics companies in the world, has put out on a GitHub, because you can, if people don't know, ROS stands for Robot Operating System, and it's just generally a really good cross-platform way of programming robots. I had nothing to do with robots. Certainly while I was in grad school, didn't think I'd be doing robots. I've now learned some ROS and dealt with robots. Robots are one of the big things I'm now working on. But there are actually direct ways to control robots from Unity. People have done this, they're interested, and because Unity is such a powerful simulator, you can pretty much apply them directly. These systems can do as fine-grained things as simulating friction for wheeled robots and these sorts of things. You can get really deep into closed simulations of the physical world in places where it matters. Right? This is the Sawyer robot on the left, which is, I don't know, $25,000 or $30,000 robot, big factory arm that's supposed to be used for industrial things, but it's the sort of thing that you can do interesting things with. Another actually project that you can see in the link is I programmed the Sawyer robot to act in a play, because that part of this is a little bit of an aside. This isn't necessarily the main subject of this, but one of the other things that EAT has done recently as an internal industrial thing is think very deeply about human-robot interaction and human-robot relationships, and how can we make it so that they're the best possible, right? When we just have people purely focused on the engineering bottom line for robots, you can end up having people who really don't like robots who are being forced to work alongside robots. So we actually kind of did the sociology research. We did a bunch of studies. We actually ended up talking to and presenting to Rodney Brooks, who's the inventor of the Roomba and has been a great consultant for Bell Labs, and trying to think very critically about how can we make robots be as friendly to, and especially as, I guess, consonant with human goals in human well-being as we can possibly make them. Because if they're coming, we want them to be that way. So part of the process of this was working with an artist on a play starring a robot and having the robot do different things and serve different roles in this imagined universe. Another thing which has even been talked about in this class before several years ago is the ML agents part of Unity. Machine learning, whole bunch of things there. If you're not familiar with it, there's lots of different things you can find on machine learning, deep learning, AI, very trendy, maybe going places. I think it's probably more hyped up than it is. And it's kind of stayed the same amount of hype with the same kind of progress for a little bit now. So I think that's mostly holding true, but Unity does have some very exciting things with being able to simulate autonomous agents that can learn via deep learning processes. So you may not have seen these videos, I can link them later, but there's, for example, people can take these legged robots and just teach them over and over through failing to walk, how to walk, just by trying many, many things. One application would be, if they're still doing this research, self-driving cars. If you want to create a different environment, you can start to really think about, can we use a bunch of different training data to train a car to drive correctly in Unity? And can we then apply those same principles of intelligence to the real world, to the real road? And what's especially exciting actually is that people have combined the above two. So in the bottom right is an example of people doing ROS with the ML agents. So starting to train robots using the enhanced features of a digital world, namely being able to do, something 20,000 times in a couple hours without having to, expend all that energy, or especially if there's something that's going to make the robot break, continually being able to test it to make sure that you get a system that doesn't break the robot. So this is what I think is really powerful about Unity, is that it's a great system. It does all these different things from a software perspective that just works. It can make your cameras talk to each other. It can make your different systems talk to each other. But at the core of Unity and the core of a lot of the different technologies that I'm using and that are growing is this sort of 3D centered, spatiotemporal, motor centered movement, that what they're ultimately trying to do is simulate the real world. You have things that move around, that obey laws of physics, that will do these different things, and Unity ends up looking much more powerful, especially if we're talking about industrial real world applications, when it actually has this quality of being simulated and being physical. And one thing that I always like to point to, and part of what inspired me going into URTC Mix, is video games, which do really have this strong aesthetic experience through sort of sensor motor perception, movement. These sorts of things end up being the core, and all of these things are sort of peak artistic experience that I've had that I think really end up working on the canvas of spatial perception and spatial movement. One thing in particular I'd highlight is in the bottom right is a game called Outer Wilds, which I absolutely love, but is all a moving narrative story. But as part of that story, and I really think that it'd be different otherwise, is a fully simulated solar system where you're kind of able to go around, explore these different planets, and you have to actually guide a rocket ship using the principles of gravity in a way that a book can't necessarily get you to think about that, or just say a piece of music in the same way, at least. And I think the peak experiences that you get from video games, the aesthetic experience where what it's like to be in another world, and having that be so concretely related to actual physical reality, is something special that we haven't quite figured out yet. And I'm hoping that classes like the one Brad is teaching, and hopefully all of you with your projects, we can start to kind of really explore what the boundaries are, because, Unity is always advancing, all these technologies are already advancing. But I do feel that the the research hasn't quite been done. Video games, when you look at their funding, there's some really interesting creative voices, but they tend to be pretty much evaluated as entertainment, that it's about what ultimately people are going to buy as entertainment for themselves. These other industry things that I'm starting to talk about, robotics and stuff, tend to be measured bottom line for industry. But with so much that's going into simulating the physical world and the wide aesthetic canvas, as well as really just the overall usefulness canvas, I think there's a lot there. Um, just also want to point to, there's a long tradition, right, of art that has some spatial component. The Janet Cardiff sound walks are very, very good. I'm forgetting the name of the piece, but there's one she has in Central Park that there's still an archive of, that I'd suggest people do. It's a great way to see art during COVID. Um, you can go to Central Park and experience this, Lamont Young's Dream House. I'm not sure what it's doing during COVID, but an absolutely incredible artistic experience that exists outside of the normal medium of just a linear compositional piece. Um, on the right, extremely, I guess, arrogantly, is a project that I've been working on for a number of years, dealing with spatial text, of trying to make a book that you explore more like a video game. So rather than, reading it just line by line, I've got, what is it, like 2,000 pages of mostly nonsense poetry, but that has little nuggets of coherence, and you're supposed to kind of flip through between them. But these are the sorts of things that people are doing more and more, I think, and becomes much, much more possible and accessible with these 3D technology growing increasingly. Oh, looks like there's some chats. Let me take a moment to
There's
It's
pause.
about the
always
dream
things
house.
in the chat.
Yeah. It's just
Oh,
running commentary
nice.
on what you're saying, Ethan's.
Could
Good.
you repeat the name of the soundwalk artist? Soundwalk
Janet Cardiff.
Janet
Actually, I'll type
Cardiff.
it here.
Thank you.
I just put her in. Yeah. She
Yep.
also did the 40 voice motet, the thing with all the
Yeah,
speakers, where each speaker was a separate singer. It's a remarkable piece.
I haven't gotten to see that, but I've really wanted to. Yeah, people doing really good work. So, kind of concluding with this is another stock image, similar to the one I started with at Art and Tech, and this is when believe I googled metaverse, and there's a bunch of different terms. Metaverse, mirror world is one that I've used a bunch. Different kinds of hyper reality type things, and there's a lot of discussion, especially in the industry sphere, I'd say, of what will the future of augmented reality be? What happens if you have all these different sensors, all the cameras going at once, so that you can basically digitally make the Borges map, right? That not only do you have a miniature map that you can use to navigate yourself, but actually a one-to-one copy of the physical world that, I think in the case we're talking, not only has all that kind of visual information so that you could fly through it virtually, but also has everything else that we can't really see, the things that we get from sensors that might do things beyond our normal range of hearing, our normal range of seeing, that can use the kind of AI analytics that we're starting to talk about, that can do predictive things. If, say, that traffic intersection I mentioned earlier, you can actually just see it physically in you of, oh, this tends to get busy at 4 p.m. Or even better, you can see kind of the patterns of the air that we've all been made much more aware of by the pandemic. These sorts of information, scientific, engineering, otherwise, that end up being useful to our everyday lives. And a lot of the discussion right now has been about, oh, this is a great platform. Facebook right now is after this. Apple may very well be. There's always rumors that they're doing a headset. This is thought to be a great place for basically corporations to move in. There will be ad revenue, all that stuff. It'll be a big platform, more like, say, Facebook or something, that everyone's supposed to be on, and you have different ways of influencing. But I want to think about what if this is more connected to those aesthetic experiences that I like to talk about, that we like to talk about in this class. What would it look like to really build something that's not just another platform that's ultimately being sought by kind of one corporation that's rent seeking or another, but was these new kinds of experiences that take all the research that artists have been doing and that scientists have been doing and combine them into something that is maybe more than an artwork, but also more than just your bland everyday thing that is able to cross those two experiences. And I think that this is ultimately where I want to be going in industry as well as artistic career, that everything's moving ultimately towards building things for people, right? When you think about um, the clearest kind of merge of art and technology before the rise of computers and transistors and all the Bell Labs stuff, I would say was architecture. That architects are people who are really thinking practically about what can a building do? What does it need to do to serve our everyday life functions, industry, of living, of all these things? But how do I also make it beautiful? How do I make it aesthetic? And how do I capture these things? And there's a lot of architects who not only made good works of art, but actually made spaces that people end up inhabiting and admiring for centuries, possibly longer. I think a lot of technological art right now, and especially a lot of technological products, are much more on this short term, whether it be entertainment for advertising or whether it be, these kind of like quick systems you're building, the next cool thing. It's a great little bit of research that you can talk about, but ultimately it's going to be outdated. And I think as long as we're trapped either in the artist or in the engineering mindset that I talked about at the beginning, as long as we're just in art or technology, we tend to focus on these shorter term, smaller scale things. And I think the best way to combine them, and I don't know how to do this, I don't know how to do it myself. I'm trying to find out, I'm trying to do the research for it, is to build these sorts of spaces that are shared, that do more than any of the different parts alone. And I hope that, I haven't added any images to this slide because I don't really know what it looks like yet, but I think that's maybe what we can start to think about. And questions like, how do we put sound in the proper 3D worlds? How do we use the 3D worlds to make new sounds, new kinds of music that we've never made before are the crucial questions. And we're going to need people with both sets to help us answer the questions. So that's pretty much the presentation as I've done it. I think I've got about, right about 7:30 when I was hoping. So we can kind of have questions. Let's feel free to get into a discussion. If you have disagreements with me, think I'm being too vague and that this is all nonsense, or that, obviously there's no way to build any kind of shared space without it being corporately owned, I want to hear that as well. But also, even if you don't want to talk now, please do feel free to reach out to me via email. Once again, I can only speak about myself. I don't know how much of this is a growing field. If there are more jobs like this, I very well could lose my job before the next time this class happens. Everything is unpredictable, but I would be happy to help or talk about some of these questions, or just even talk in general about whatever. So yeah.
I was just going to jump in and say that what Ethan was saying at the end there is pretty much what's driving me these days too. It's this idea that there's just such vast potential and this vast unexplored territory. When I first entered computer music, back in like 1982, that was kind of the feeling then. This is before John Chowning really released the FM patent on the world, and before digital computers couldn't really even do digital processing at all in real time. But you just had the sense that anything was possible, and again, that's what That's what's going to be. And the thing I like about this, Ethan and I tend to sound too much like Unity evangelists sometimes. But like, if you look at those video games, the really big ticket items, they have like, 200 programmers, and just like, it's like looking at the tech crew for a Hollywood production, which is kind of what it is. The thing I like about Unity is that it empowers the individual again. I can sit down and I can create these worlds. Nina can create that wonderful Japanese garden, on her own. Is it going to be as, with the physics of the real world? No, but it's going to have other stuff, other stuff that only Nina could think of, or only I or Ethan or some of you can think of, in imagining what this is. Um, yeah, and yeah, I mean, I tend to be a bit more plebeian, I think, in my imaginings, but I think there's, what some of the stuff that say Laura showed last week. She's been getting into writing a lot of very interesting shaders lately,
Yeah.
and they do some pretty amazing stuff. But
I looked at her class actually, and I think that she's very much doing the kind of good work that I hope to be doing, and I hope to encourage other people to be doing, of really trying to think of how we can build fundamentally new spaces using this kind of technology.
Right. And Seth's involvement with, looking at the spatial aspect of sound and sound generation and things like that. Seth.
Yeah, I should also say, yeah, Seth is a longtime Bell Labs artist in residence, and I think one of our stars because of how much he is really able to bridge the gap between researching engineer and scientist and artist. He's been absolutely great to work with, and he's another great person to get in contact with. I should also mention we have access to a large anechoic chamber. So it was the quietest room in the world for like 50 years or something. And we also have a really cool room that we call the antechamber that is 64 speakers in surround sound. And we basically have a policy that if you want to come out and spend the time in New Jersey to figure out a really cool and unique way to use these spaces, we will absolutely welcome you to come in. We will get you set up with the technology and show you how to do it, because we want especially more students and more creative people to be using these spaces and using them for the fundamental research that they were intended for.
Yeah, that's a good point. And yeah, we've got like a nice pipeline there with both Ethan and Seth involved. That's where I probably part ways with you guys, because you still have one foot kind of in the real world, and I just want to sit out on my island and like put on my virtual reality goggles and just kind of bliss out. So, but yeah, it's a remarkable opportunity. We have a chance to really pretty much define an emerging field right now. And yeah, like I said, I echo a lot of what Ethan was talking about. I know, Ethan, I want to make sure you appreciate somebody else who's on this call. Candide, I think you know her work. I talked to you about it, but she's also very involved in imagining what these new ways of presentation might be, new storytellings and things like that. Yeah, she's finishing her doctoral dissertation now. Actually, she brought up an interesting thing that I want to maybe raise with you to see if you've encountered it. As part of her dissertation work, she's trying to find ways of notating these new systems. Is that something that you guys have grappled with in terms of trying to nail down what you're doing?
Not so much, right? We know as much as we want a new notation system, but we haven't found necessarily a good way. And right, what ends up being so confusing is that these standard ways that you'd think of doing it that are very possible, of primarily using coordinates, end up being very, very difficult to visualize. So that, right, if you have sound on a space, you end up getting, right, a really big list of something like a JSON file that is much more computer readable than human readable, right? You would actually want to have like a map, for example, that can show these things. And I think this is where notation and mapping end up converging in some way. That when you look, I mean, for the mapping project, right, I was all for, we not only need to be looking at your standard topographical map or your road map, but also these much more conceptual style maps of the ones that are more artistic, that say have places of more importance that are bigger, that exaggerate different spatial qualities, because I think perception, how people perceive these complicated things, is something that needs to be understood when making these technical systems if we're really going to be able to use it, right? I think a talented musician, not like me, would be able to look at, musical notation, and as imperfect a system as it is, you can get a real sense of what the piece is just from looking at the notation. And you need to kind of, it becomes a visualization problem, like the sort of thing that Mark and Ziang were working on.
Yeah, it's a challenging project, but I can see the efficacy of having some kind of good system like that.
Yeah.
Hmm. Yeah. Um, I also want to point out, Ethan, I don't know, did you overlap with Mengtai Zhang at all?
Yeah, I see
Uh,
here that he's here
yeah.
with his camera off.
Yeah, yeah. He's coming in. He's finishing his doctorate at RPI, and he's looking at Unity as new ways of storytelling, which is kind of a big area too. Oh, Candide's got her hand up. You should just like shout it out, Candide. What do you got to say?
I apologize because I think that I am a little bit, this place is a little bit noisy here. Can you guys hear the construction now?
Yeah, it sounds
Yes.
like crickets in
So,
the background. You said you were in the Colombian
well,
jungle, so I assume
also,
that's
yeah, but we are also building a place here, so you're going to hear a mix of like construction and crickets and things like that. Um,
perfect. Perfect.
so thank you so much, Red, for bringing the topic of the notation thing. Evan, thanks for your generosity on sharing all this with us. I have a very similar background from yours, but the opposite. My grad was in music, in piano, but then I took a lot of philosophy classes, and now I'm in a PhD. I'm kind of trying to convey all the facts. And I'm also a biotechnologist, so I do this thing of art, science, and bio studies in like a crazy thing. And what I wanted to ask you is exactly about this border between creating what we call useful art, right? There's about a border. So the school where I developed my PhD is named Architecture, Arts, and Design. So, and I am really intrigued by this combination in which we develop a kind of art that is useful for the world, but at the same time, our freedom to create like contemporary art and conceptual art. Yesterday, I was talking in a conference about this work that Brett was mentioning, and I nowadays I consider this work like totally in line with artists like Bill Viola or Larry Anderson and people that they are, although they are working with technology and all that, they are not really thinking about creating something that I would say the technology that is behind the work will be used for many things, but the work itself is not aiming for a specific use or something like that. So I've been submitting this work like in very different fields, from social
Mhm.
sciences to arts to technology. It's very interesting to see how the work can cross that. That's the gain of transdisciplinarity, but at the same time, like being able to tune the speech to explain the work and why you're doing an art that is not useful and why you're doing that, right? So I work across virtual reality and nomadic practices and things like that. It's a lot of things. I barely have words to describe all that, but I wanted to hear your approach to this idea. What do you think?
Can you? I think I might have missed the keyword over the sounds. Could you just restate it very briefly?
I'm so sorry. Yes, absolutely. So it is idea you said about creating art for this new world. So what I'm calling like with like apologies on the word, but like useful arts or creating technology for a world that will need us, and our freedom to create artistic projects that they don't have any kind of commitment to being useful or to be like having a specific goal on achieving something in terms of technology.
And I think a fundamental thing that, the way I think of it, tends to be is that our sense of what the useful is ends up being very restricted, I think, comparatively, and I think should really be expanded. right, the Bell Labs researchers that I was talking about that made some of the fundamental, key advances of 20th century technology were not doing things that were strictly useful, right? The fortunateness of the Bell telephone monopoly is that they had many different researchers on staff who were doing things that interested them, that they were passionate about, and did not have any direct connection to the bottom line of AT&T. And right, plenty of those researchers ended up doing things that may not have been directly related to the telephone business, but gave us advances. Some of them ended up being actually very key. There's Claude Shannon who did the information theory, but Bell Labs has, what is it, like 9 Nobel Prizes in physics just from people mostly doing this unconnected research, right? Discovering cosmic background radiation and proving the Big Bang Theory, I think really ultimately had no bottom line effect on AT&T, but they were a long-term enough institution that they could make the bet of we should keep funding fundamental scientific research because this advantages us enough that in the end, maybe somewhere long down the line, we are actually going to get use out of this. And it ends up looking a lot more something like a university, right? That rather than going with this paradigm of all that we're funding must be useful, it's much more of this sense of knowledge is just inherently good. And I think artists are operating on a similar thing of trying to look for things that have values entirely out of usefulness. And right, I think that that's end up how you're doing it. If you're short-sighted and trying to think about what's something artistic I can make that will hit exactly the right demographics, get profit, it ends up being, certainly it can be good, but it's especially not going to be fundamentally new in this way that we really need. And I think it's a real discredit to a lot of companies into the engineering mindset in general, that it ends up being, we end up being so focused on these little incremental things. It's only things that we know beforehand will improve profit motives or whatever. And I think that the key things that Bell Labs as a communication company needs to tackle, right, is that we have great networking. We have 5G or whatever, cool, we can get some more cell towers, people's phone calls will be better. But the key thing that EAT likes to talk about is when you have phone calls, you have video calls, you have texting, all these things are working. And yet we have a global pandemic now where people are using this technology more than ever, and everyone feels extremely isolated and cannot figure out a way. No one has been able to figure out the problem of how do we get deep human connection, like the sort of thing that we get face to face. Why is it that sometimes we get that face to face and other times, even when we're face to face, we don't get that? And we think it's only by working with artists who are fundamentally concerned about what it means to be a person, these like, music especially. The key paradigm that Dunal has had us focus on is music. There's a kind of emotional communication that comes from music that is not really conveyable in normal language and certainly not in something like a text message. How do we work with composers and such to find out these key parts of emotions, of aesthetics that end up being a lot of what's missing in current technology? And if we work with them of like, deliver us a product, we're never going to get that. We're going to get something that's mediocre and doesn't do the fundamental long-term research that we needed to.
Max Gupta, one of our intrepid undergrads, had his hand up, and you've got also a question in the chat we'll get to from Ming Tai.
Yeah.
It's kind of interesting. Max, what were you going to say?
Yeah, may have lost my train of thought a couple times there, but
We all did.
um, I mean, I was also interested in Candid's question of useful art, but then you started to talk about fundamental research. And I mean, while these projects that you showed were like incredibly thoughtful, I don't know how to like phrase this question, but it doesn't seem like those projects had anything to do with fundamental research as it as it is. As in fundamental technological research is always going to be fundamental engineering research, correct? Like,
Mhm.
I think we have to agree on that. But then there's also the aspect of like kind of almost transferal of human consciousness to a digital sphere, which is something that is an attempt, is what you're saying, that's the attempt. So there's like the logic in the fundamental research, and then there's the attempt in the reach of kind of this transferal that you're mentioning. But I think they ultimately belong in different spheres, or you can also disagree with that.
Mhm. So I think you're absolutely right on the count that the fundamental Bell Labs research that, say, Clint Davison, our first Nobel Prize winner, was doing, nothing really to do with art necessarily. And certainly the stuff that EAT is doing would only be fundamental research in kind of these much more vague fields, say, of human psychology, design, usability, these sorts of things, which are not in the hard sciences. Is our belief, and I think especially much more my belief, and this is much more contentious, so I don't mind if you disagree with me at all, but I do think that while the stuff that we're doing doesn't necessarily impact on the fundamental research, that fundamental researchers do really benefit from their creative engagement. Right, this is a very fraught example, but thinking, for example, about fundamental physics, especially in the first half of the 20th century, that so much of the questions are not just about experimental methods or measurements or working out the mathematics, but it is these kind of much more creative things around what are the thought experiments? How do we make these things work? How do we make special relativity or the Copenhagen interpretation work together? And, you know, I am by no means qualified to say this, but my sense of looking at a lot of sciences is that for whatever reason, that kind of more philosophical and creative side of some of the fundamental sciences has become less pronounced. That, you know, we have, for example, the Copenhagen interpretation of quantum mechanics, and there hasn't really been as much of a major paradigm shift in understanding, even while people are still debating what even this means. So part of our kind of long bet is that part of what we need to do to have the best fundamental research is to have scientists and engineers who are engaged on perhaps a deeper level than they'd be used to thinking of, especially from what tends to be the more narrow senses, I think, of a corporate lab. I hope that that answers some of it. And what I said, I'm happy once again for you to disagree with or quibble with if you like.
I mean, I do think, I thank you for that. And I also think like a lot of Bell Labs' initiatives in the mid 20th century, I mean, were funded well. I mean, that gave obviously like artistic license in some respect in terms of thought, but also just uh, it had to do with the, you know, the Second World War aftermath, the Cold War as well, like issues that we don't face as a society today that kind of also fueled, I mean, all of these, you know, the need for advances in fundamental research. So if you're looking at the need today, what would you say that need is?
I mean, it's more difficult, right? Because you have the concrete needs, which seem so clear. I think the things that I personally would point to, I'm not making any statement for Nokia or Bell Labs here, is the issues that we talked about around communication, that I think there is a real societal breakdown in mass communication, in news media, and these sorts of much more political problems, which right are a civics problem fundamentally, but I think could be addressed more. Right, if there's a technological solution, we should be absolutely exploring it. And my worry is that the main players in this space are fundamentally driven by sort of not the right incentives to do the fundamental paradigm shifts we need. The other thing I'd point it to, which once again has really strange incentives, but is global warming that, I've been in different contexts and business meetings where a lot of the fundamental environmental shifts are being taken seriously as business things, right? That will happen, that will impact, supply chains, industrial things, living conditions for people. And, you know, I don't think that the incentives seem to have really properly kicked in long term for companies be doing the necessary work for that, but I could see that being the case of global warming being the kind of thing that has the potential to be a World War II level threat that needs to be responded to in this way.
I think this is where Candide's comments about, absolutely useless stuff, that may be where we can actually ultimately find solutions. I mean, we can't predict that, but the fact is that, our current ways of thinking aren't providing those solutions. And a lot of it does come down to economics. Max, you're kind of hinting at this too, but you should check out Meng Tai's comment in the chat about the difference between then and now, for example. And unfortunately, these concerns are infecting the university now, and it's places like music departments that still retain the freedom to do, Candide said, absolutely useless work, because a lot of the sciences and engineering are becoming much more outcome oriented, for example, and again, it's being driven by economics. Yeah, but we'll see what Ming Tai has to say.
Yeah, so I've read the comment, and I certainly cannot, not an economist, not a government special, none of those things. I just kind of have a layman's understanding of the history of Bell Labs and such. But my strong sense, right, is that the government had decided that the Bell Labs telecoms monopoly was unfair, and they did break up Bell Labs. If I were to be kind of a civic-minded capitalist, I would largely agree that the distance calling when Bell Labs had that monopoly was definitely a racket, and it was weird for the government to have this. What they did, though, was that they broke up the telecoms monopoly so that Bell Labs lost its vertical monopoly of all the equipment to all the services to all this, and also the horizontal monopoly, so that now there are many telecoms companies, right? All the different baby bells split into, now we've got Verizon and AT&T competing with each other. We've got new ones like T-Mobile. They're all competing with each other. What they then seem to do, and I'd love to read more of the history of this, is that they then said, okay, these companies, now that they have their profit and competition incentives, we're not going to really enforce that, so that now Verizon and AT&T and T-Mobile, which are beloved customers, I won't say too much bad about them, but they don't really have the good incentive that you expect from competition and doing kind of fundamental research, right? It'd be one thing if you had the AT&T Bell Labs versus the Verizon Bell Labs, and they're going so fast that they're going well beyond the pace of the mid-20th century. But I think what we've seen is the opposite, and that the arrangement we've managed to fall into with corporate regulation, right, is that, I don't know, I think whatever we've done it wrong, because I do think we're not where we could be and where we should be. Part of that might be the difficulties just of, it's harder to do research right now with all we discovered, but I think part of it are the bad incentives right now in the US, and I think generally the world's companies and research funding.
I think the pandemic combined with the recent presidential election just really exposed a lot of these fault lines, and yeah, my response is to just go downstairs to my studio and just start making weird noises, which is a very good one. But I guess that's what we're left with. But again, I still retain enough of a optimistic outlook to think that out of this, Candide was also talking about how these things can fit in a transdisciplinary sort of situation. It's really hard to kind of fit in these projects we're talking about. You do this unity thing. Where does it actually kind of situate itself? And I think that's a symptom of this emerging field. And to a certain extent, I hope it's always like that, because I'd hate to see it become kind of ossified, where it becomes just one thing that you do. To a certain extent, that's happened in the computer music world. I mean, I don't read the computer music journal with the excitement that I used to, back 30 years ago, because I kind of know what it's going to be about, and that's kind of too bad. But anyhow, we're kind of running almost out of time here.
I have one question if I
That's what I was
Nina
going
has
to ask for.
one.
I was going to see if anybody else had
5
anything to
minutes.
say. So Nina, take it away.
I wanted to go back to the more artistic questions, and it's also for you as a philosopher, I guess, as an artist and person who knows so much about technology. So you were saying that you know a lot, obviously, about technology, and you've learned a lot during the years, but you also had some background. How do you compare this creative process to, let's say, sorry, I don't really have it so well formulated, but I'm thinking, how do you balance your knowledge of technology with creative ideas? For example, do you still always, I guess this is in my head, a traditional way of approaching a work. Do you still come from the idea and then you think of the technology that could enable, the work, or do you have other approaches, or maybe you have some observations of your colleagues? I was just curious about that.
So this one can actually get a little biographical answer. That when I was in sound art programming before, I was still really confused about what I wanted to do. So I was really trying to find ways to use the new technology in order to build something good that I liked, but really it was this hybrid goal of, how can I make stuff that is kind of like, will start to hint at the future and really address things in this mass way, as well as be artistically satisfying. And the nicest thing about my job is that I've stopped trying to do everything at once. In my job, I am like pretty strict about, I'm trying to answer these big questions around how to build kind of the next thing. And I hope to continue in that. I hope to be able to find people who will pay me money to do these things. But then in my artistic work, which I've continued, I've actually been fully free, where I try not to think at all about these kind of much more practical questions of use and stuff. And even for whatever reason, my aesthetics have much more tended towards things that are of different forms and, might be of more kind of long-term validity. So I think the artistic piece that I'm happiest with was, I'll send the link after. It's an app called Prompts that you just install it on your iPhone, and then it gives you kind of a what's the Eno card deck thing called?
Oblique strategies.
Yeah, it kind of gives you an oblique strategy or a Fluxus-like prompt just at some random time in your day, and supposed to kind of change your thinking. Not something that will ever gain success or be massively downloaded, but I'm really happy with it, and people I respect have downloaded and liked it. The other thing I'm trying to do is this giant, 2,000-page concrete poem. Apparently, there was one book of concrete poetry published in the United States by a single author, and that was his last book of poetry ever published, because no one would publish him after that. So it's really not something you do. But for me, the question was, I love video games. I love this aesthetic of spatiality, but I also really prefer artwork that has lasted a long time and has lasted a long time. Meanwhile, my apps on the App Store, even my thesis project, they have pretty short shelf life overall. You have to be really vigorous about updating them. So this giant concrete poem came from the question of, how can I take what aesthetically I like about video game, these aesthetic experience, and make it in a way that can, say, survive for at least 100 years, trying to do it in a book format, something that I know has survived for a long time and I'm hopeful will survive. I've been thinking a lot about this question in, sometimes I'll even make these convoluted technical pipelines, but I want to have the result be, you know, ultimately just a wave file, which is something that I'm confident will be translated to other medium in the future as we listen to music in different ways. Yeah.
Thank you.
Okay, gang. Yeah, I think we're going to call it a night here. And this is a really terrific and fascinating discussion, Ethan. I really appreciate your willingness to share your ideas and, you know, your thoughts. Yeah, I'm going to stop the recording now.